All right, well, welcome. So I'm going to go ahead and work through this. I'm working through some new software, so I want to see if this is actually working up here. And then we'll just go ahead and go through the process. So I guess that's not showing up on that streaming software, so that's fine. But I'll go ahead and get started with this. So, all right. So what I want to do is just kind of go through the quiz here. It's the first, what happened to it? There we go. All right. So we're going to follow through the Polynomials Quiz. This is the first quiz in the Polynomials unit, and it says graph the following polynomial and list each zero with their multiplicity. And so I guess obviously I'm not working on my full capacity here because nothing is set up like a normal live stream. Waiting. All right, there we go. Now let's go ahead and get started. So it says graph the following polynomial and list the zeros and the multiplicity. So the one thing, we kind of looked at a couple of different things. First thing, we wanted to identify the end behavior. And if we were going to identify the end behavior, now this wasn't part of the, finding the end behavior wasn't a part of the, actually, let me check. Finding the end behavior was not actually a part of the, as far as finding the zeros, but that does help us graph it. So to find the end behavior, basically what we want to do is understand if we were to multiply this out, what would it produce, right? So if I did y equals negative 3x. Now, if I was to expand out 2 minus x, you might want to rewrite that. You might want to rewrite this in another form. For instance, negative x plus 2. And if you were to rewrite that, negative x plus 2 times negative x plus 2, either way, it's going to give you a positive x squared. Right? And if I was to write a 2x to the fourth, now obviously that would give you, let's see, so 2x to the fourth, that's going to be a cube, that'd be 16. 16x to the fourth power. So whatever the answer, whatever that may be, that's what, it's going to provide you 16x to the fourth. And therefore, you're going to end up getting, if you were to multiply these all together, 3 times 16 would be a 48. So this would be a negative 48. And if you add the powers here, that'd be cubed, that'd be x to the 7th. Now, understand, I don't know what the rest of the polynomial is, but I don't need to know the rest of the polynomial. From this information here, I can determine that the end behavior, based on it having an odd degree and a negative leading coefficient, is going to rise to the left and fall to the right. So just based on that information, I understand what the end behavior is going to be. Now, the next thing is I want to identify the zeros as well as their multiplicity. So what I'm going to do is, since if I want to find the zeros, I'm going to set my equation equal to 0. And I can see I have a product of factors equal to 0. So therefore, I can set each and every one of them equal to 0. 2 minus x squared equals 0. And let's do it down here. Crap, I kind of ran out of space. Yeah, that's all right. 2x plus 8. I guess I'll do it down here. Well, shoot. I want to fit it all in there, so I'll just draw them write them a little bit smaller. So I have negative 3x equals 0. I have a 2 minus x squared equals 0. And I have a 2x plus 8 to the fourth power equals 0. All right, now I'm basically just going to solve all these. Well, divide by negative 3 here, so you get x is equal to 0. So therefore, I have an x-intercept at 0. All right, here, if I go ahead and take the square root to both sides, I get 2 minus x equals 0. All right, I'll just move this down. So you take the square root of both sides, and then you get a 2 minus x equals 0. Add the x to the other side, you get 2 is equal to x, or x is equal to 2. So therefore, I know there's a 0 at positive 2. All right, and then the last one is I have a 2x plus 4. So again, you would just undo the fourth power by taking the fourth root of both sides. But hopefully you recognize, just like taking the square root of both sides, that's just going to undo the power, and that doesn't do anything to the 0. So therefore, you're left with an 8x plus 4 is equal to 0. I guess I'll just take the fourth root. Show that. And then if you subtract the 8 and then divide by 2, you have a 2x equal to negative 8. Divide by 2, x is equal to negative 4. Okay, so now I have a 0 in 1, 2, 3, 4. So I also 0 at -4. So my zeros, I'm going to write in set notation here, are going to be at, let's see, 0. And again, now we also wanted to make sure we include the multiplicity. Now, when I'm using multiplicity, I told students that my zeros are always going to be included with a multiplicity of 1. You can see that the multiplicity, again, is the power of the zeros. So 0 has a multiplicity of 1, but since I'm using set notation, I'm not going to write it in there unless it has a multiplicity other than 1. So for instance, here I have 2, which has a multiplicity of 2, because that is the power of the factor, whereas I have another 0, -4, and that has a multiplicity of 4 because that is the power of the factor. And I didn't really choose numbers now that I think about it. You can see them, you can get them confused with the zeros, but they really have no relationship there. All right, now the interesting thing about the multiplicity is that it does tell us the behavior of the x-intercept. At -4, since it's even, that means it's going to bounce. Well, since it needs to end up here, I can see that it's going to bounce upwards, right? At 0 has a multiplicity of 1, so I know it's going to cross, all right? And since we're going to be coming up here, it's going to cross. And then at 2, it also has to have a, since the multiplicity is even, means it's going to bounce. So therefore, it's going to open down. So again, just make sure you understand when it's even multiplicity, it bounces. When it's odd multiplicity, it's going to cross. And then I'm basically just going to connect my behavior here. And that was the graph that I was looking for, or something into that form. But basically looking for that you had the zeros, the multiplicity, the end behavior, and you could roughly go ahead and get a graph that was going to resemble that. The next thing we worked on is the expanding the binomial completely and then to simplify the solution. So rather than multiplying this out, which many students try to do, which I wouldn't recommend, we can just kind of talk about the patterns that we found in class via the patterns of the powers, which would be like the binomial expansion, as well as the patterns with the coefficients, which would be like Pascal's triangle. So in this case, basically what we want to do is go ahead and rewrite it to x plus and -2 to the 6th power. Okay, so therefore we could represent that x was my first term, -2 was my second term, and the first thing that we talked about in class was understanding the pattern of the powers. So remember we started with x to the 6th, -2 starts at 0, and then that first term it always starts at the highest power of your binomial expansion and then goes down in descending order, whereas the second term starts at 0 and goes in ascending order. So then we had x to the 5th, -2 to the 1st, and then we went for x to the 4th. Jeez, come on, -2 squared plus, x cubed times -2 cubed, plus we add x squared times -2 to the 4th, plus x to the 1st times -2 to the 5th, and then plus, last but not least, x to the 0 times -2 to the 6th. However, one thing that we recognize is that if we were to simplify this, this does actually not produce the coefficients of our binomial expansion, because one thing we have to take into consideration is the combining of the like terms, which comes from basically Pascal's triangle. So therefore, we need to go ahead and understand where obviously Pascal's triangle represents the coefficients. Basically, when you have your terms of 1, obviously that's going to be a little bit different here because now we're going to be utilizing a -2 to the power. However, if I go ahead and create Pascal's triangle, I see that this would be the coefficients of an expansion for n is equal to 2. And you can add the next two terms. So it always starts with 1 and ends with 1. And therefore, you can do 1 plus 2 to give you 3. 2 plus 1 is 3. And then to the next row, you can see how I'm going to get 4, 6, 4, and 1. And then what we're doing, the 5th expansion, right? So I'm kind of running out of some space here. Let's move this over. Okay, so 1, 5, 10. Oops, that's supposed to be a 10. 10, 5, 1, and then 1, 6, 15, 20, 15, 6, and 1. And I can stop here because what we discussed in class is the second term tells you the power of the expansion. So you can see that this would be the coefficients of a binomial raised to the second power, third power, fourth power, fifth power, and sixth power. And that's what we need is right here. So what I'm going to do is I'm going to take these values and I'm going to multiply them by each term. Now, again, for a binomial expansion of 6 terms, I should have 7 monomials. 1, 2, 3, 4, 5, 6, 7. And therefore, you can see there's 7 rows, 7 values in this row. 1, 2, 3, 4, 5, 6, 7. So I'm just going to take these values and multiply them out. All right, so 15. I'm putting them in parentheses just to remind myself that I'm inserting them from Pascal's triangle, and I'm going to have to multiply them all out. And then the last thing I want to do is just go ahead and simplify everything. Okay, so obviously x to any raised to any one of those powers is going to be fine. You don't really need to do anything there. The next thing we just need to do is simplify the -2 raised to powers. And then obviously then we'll multiply them by our coefficients from Pascal's triangle. So I'll kind of do this in 2 steps so you can see the work. So in this case, I have x to the 6, -2 to the 0 is just, going to be 1. Then the next term I have plus, let's see here, it's going to be a 6 times -2. And that's going to be times x to the 5th. It's so weird. Okay, times x to the 5th, so I'm just taking that -2 and plugging that back in front. And then plus over here, I'm going to have, let's see, -2 squared is going to be 4, so that's going to be a 15 times 4 times x to the 4th. Here, -2 cubed is going to be a -8 times 20, so it would be a 20 times a -8. And that'd be an x cubed. -2 to the 4th power is going to be positive 16. So that's going to be positive 15 times 16 x to the 4th. Not x to the 4th. I'm sorry. That's supposed to be an x cubed. That's supposed to be an x squared. Okay. Then we have -2 to the 5th, which is going to be 32. So we'll have 6 times 32 times x to the 1st. And then we'll have x to the 0 is 1 times -2 to the 6th power, which will be 64. All right, so now let's just go ahead and clean this up a little bit. And again, I told students they didn't have a calculator, so if they were making some mistakes, I was pretty nice with them. But I would hope that I could at least see this effort. And then if we were making mistakes from here, those would be kind of minor mistakes. All right, so x to the -6, this would become -12, x to the 5th. 15 times 6 is 60, so plus 60. X to the 4th. 20 times -8 is going to be -160, x cubed. And I would have expected all students to be able to kind of get to that point. However, for the next one, 15 times 16. So hopefully students remember 15 times 15 is 225. So 15 times 16 would be 240. So plus 240 x squared. 6 times 32, the way that I kind of did this is I knew that 32 times 2 is 64. So 64 times 2 again, which would be times, in general by 4. 64 times 2 would be 128. And then if you added another 64, that would represent the multiplication of 6. So let's see, 64, so that'd be 128 plus 64, which was 192. And again, if students made a minor mistake there, I was pretty forgiving with their mistake. I really wanted to see the exponent. I wanted to see the coefficients from Pascal's triangle. And I wanted to see that they could evaluate the -2 raised to the certain powers. That's what I was looking for. And then obviously if they simplified it was just kind of some extra points there. All right, the next one is find all the zeros by factoring. So a couple of different things that we looked at. We did look at grouping and we looked at factoring trinomials. In this first one, when we want to find the zeros, we're going to set it equal to 0. And then if we're going to set it equal to 0, when we have 4 terms, we're going to want to use grouping. Now, it was important that when we set up grouping, we don't want to change the problem to a multiplication problem, nor do we want to change the solution. So there's a couple of different ways I told students to do this. But I said group the first 2 terms and group the second 2 terms. But just be careful. If you're going to group this term here, make sure you have this as 2x plus 3. right? Because if I was to distribute that negative back over, I would have a negative 2x minus 3, all right? Now, once you have grouped the first two terms, now what we can basically do is go ahead and factor out common factors. So in this case, you can see I can factor out a x squared. By factoring out an x squared, I'm going to be left with a 2x plus 3. And again, we want to keep that 2x plus 3, so therefore I'm going to factor out a positive 1. Well, since there's a negative there, remember it's now going to turn into kind of like a negative 1, and that would just remain as 2x plus 3. So you can factor out a 1 in front of there, and since that negative is going to turn that to a negative 1, now you can see that both these expressions have a 2x plus 3, so I'm going to factor that out. And that's going to leave me with a x squared minus 1. So a lot of students had trouble with this. They had the 1, 0, negative 3/2, but then they had trouble with this x squared minus 1, and that is just what is left over. And then remember, we can go ahead and factor that down. You could set them both equal to 0. Plus 3 is equal to 0, so therefore x is equal to negative 3/2. And then this one you'd have x squared minus 1 is equal to 0, so therefore x is equal to plus or minus 1. And we could go ahead and set everything in set notation to keep everything nice and tidy. For the next example, we can see a trinomial. So we're going to try to be thinking of factoring in terms of trinomials. So the first thing I recognize here is that I can factor out a common factor, which is 2. So if I factor out a common factor 2, I get x to the 4th minus 10x squared plus 9. Now, basically, I might not be able to factor this, but maybe I can think of something that is factorable that is very similar. Like, for instance, x squared minus 10x plus 9. Right? Hopefully, you recognize what two numbers multiply to give you 9, add to give you negative 10. I can factor that to be x minus 9 times x minus 1. Now, this problem is very, very similar. It has the negative 10, it has the 9, it has the x's. So the factored form is going to be very similar to this. The difference here is that when I multiply my factors, I don't want to get x minus 9, I don't want to get an x squared, I need to get an x to the 4th power. So all I'm going to do is just raise the powers of my factors. By raising now the powers of my factors, now I can go ahead and go ahead and factor this, and you can see when you multiply that, that's going to give you x to the 4th. Now in this case, you could go ahead and do the zero product property like I did over here, or we could also work into writing the linear factorization. And I like doing the linear factorization, or at least understanding that factorization, because one, that reminds me that when I have x squared minus 9, I'm going to have plus or minus. A lot of students forgot the plus or minus here, so it's nice to understand the factored form so you don't forget the plus or minus. And it's also helpful doing it this way because then you don't write 2 as a factor, because 2 is not a factor. 2 does not make any of these equal to 0. So therefore, 2 is not a 0 of the polynomial. The only the only zeros of this polynomial come in the form x minus c. And if you remember, that was our factor, that was our given factor. When you have x, and when it's in x minus c form, you can find your zeros. So even though I didn't ask for linear factorization here, you can see that the format is going to be plus or minus 3 and plus or minus 1. All right, but 2 is just a scalar, right? That is just vertically stretching the graph. That is not adding an x-intercept to the graph. And again, it wouldn't make sense to have a 5x intercept for a polynomial that's raised to the 4th power. All right, and question number 4 said, write the function in vertex form by completing the square, then determine the vertex. So remember, when we're completing the square, we want to create a binomial squared. And a lot of students had trouble with this one because, it didn't look like a regular quadratic. But, in this one, what we really want to do is we want to create a perfect square trinomial. And I wrote out for students a lot of perfect square trinomials for them to really kind of understand, which ones, what we're looking for. For instance, x squared plus 2x plus 1. That can be factored down into x plus 1 squared. If I have y equals, x squared plus 4x plus 4, that can be factored down into x plus 2 squared. And so you can see this one was very similar, right? But actually, this is just the negative. If I have x squared minus 4x plus 4, that factored form is x minus 2 squared. So really, I just need to add a 4 here, right? But again, we just can't randomly add a 4. But if I add a 4 and put those in parentheses, I have now created a perfect square trinomial that I can factor down. Just remember, this is an equation. So if you're going to add 4, you need to subtract 4. okay? But now I've created something I can factor down, so y is equal to x minus 2 squared minus 4. Remember, the vertex comes from vertex form, which is y is equal to a times x minus h squared plus k. So the vertex is h comma k. So in this case, you can say my vertex is going to be 2 comma negative 4. Now, a lot of students had trouble with this, like how do you know it's 4? How do you know these are the perfect square trinomials? So remember, you can always rely on b divided by 2 squared. So in this case, my b divided by 2 squared would have been negative 4 divided by 2 squared. Well, negative 4 divided by 2 is negative 2. Negative 2 squared is 4. And that is also another way to determine that. So you might recognize 2x squared plus 2x plus not 2, but we need to get it to be plus 1. Now, again, you could just add 1 inside there and subtract 1, work it that way. However, let's just kind of do the formula, because when we do more difficult problems, we're going to want to make sure we remember the b divided by 2 squared. So in that case, your b is my coefficient of x, so 2 divided by 2 squared is 1, right? And we already kind of knew that because we knew we need 1 for this to be a perfect square trinomial. So what I'm going to do is I'm going to take that and I'm going to add it to my first two terms. But you just can't add a 1 and not subtract a 1. And then remember, there is always a plus 2 here at the end, right? Well, now I've created my perfect square trinomial, which I know I can factor down to a binomial squared. And then I can add 1. So now you can see this vertex is the opposite on the inside, and then plus 1. All right. Now let's go ahead and get into the multiple choice. So I'm doing the multiple choice. I'm not going to work through everything. I'm going to try to work through it as simple as possible to be able to figure out the answer. In this first example, I see some big numbers, and I'm like, crap, I don't want to multiply to this. It needs to write the expansion to n powers to where n is equal to 3. So basically, I want to find the third term in the expansion. Now, the important thing is, I know that the first term is going to look like this. The second term, or I'm sorry, the first term, there's the first term. If I go ahead and find the second term, that's going to be 2x to the fifth, 3y to the first, plus 2x to the fourth, and then 3y, to the second power. Now, obviously, we could go ahead and look at Pascal's triangle if we wanted to, that I created. What is the third term? That's going to be times 15, whatever else, right? You're going to have a 15 in there. But my point is, I don't really need to multiply this out. I don't need to take 2x to the fourth and then multiply that by 15 and then multiply that by 3 squared. Because look at the powers. The only example that has a power of 4 and a power of 2 is b. So therefore, just by understanding the powers of my binomial expansion, I can figure out what my correct answer would be, which is b. The next one, it says the degree is, okay, so we have a degree of 4, 0 of 4, multiplicity of 2. We have 0 of negative 3, multiplicity of 2. The graph falls to the left and falls to the right. Now that's very important, and the absolute value of the leading coefficient is 1. So be careful, it says absolute value of the leading coefficient, but if it falls to the left and falls to the right, then I know that the degree has to be even, and the leading coefficient has to be negative, right? So therefore, A is not the answer, and C is not the answer, because I know that they have to be negative. The next thing, let's go and write all the zeros as factors. Remember, if x equals c is a 0, then x minus c is the factor, right? And remember, the multiplicity would be x minus c, m, which is the multiplicity. So those are things you're going to want to remember for this. So if you have 0 as x equals 4, that means we're going to have x minus 4 is the factor raised to a power of 2. With this, the factor would be x plus 3 raised to a factor of 2. Okay. Now, can we multiply these out? Well, these are difference of two squares. I'm sorry, these are perfect square trinomials. So let's go ahead and hopefully you can multiply those out if you want to. And remember, it's not x squared minus 16 or plus 16. You actually got to multiply x minus 4 times x minus 4. But when you do that, you get x squared minus 8x plus 16. And this, when you multiply this out, you get x squared plus 6x plus 9. So now I have a trinomial times a trinomial, and I'm like, ugh, this does not look very fun, right? So basically, we need to multiply, x squared. Oh, and remember, it's going to be negative, right? So one of those is going to be a negative. So there's going to be negative on the outside. Minus 8x, plus 16 times x squared plus 6x plus 9. So, it has to be negative because that's from the end behavior. Now, the quick thing I noticed, guys, is obviously it's going to be to the fourth power. And you could use the box method, anything else here. But again, I'm looking for something to differentiate between these three answers. And the way I differentiate them is the last term. I know that by applying distributive property, I'm going to have to multiply the 16 times the 9, right? And when I multiply 16 times the 9, that's going to give me 9, 10 times 9 is 90, and 9 times 6 is 54. Well, 90 plus 54 is 144. And obviously, you're not going to get the negative because one of these negatives is being distributed in one of those factors. However, you can see that it would never be 36 or 9. So therefore, you can see that's how 9 you get there, because 9 times 16 is equal to 144. And again, the reason why it's negative is because this negative is getting distributed into one of those. So therefore, I figure out the third term without multiplying everything, and I found my answer. The next one says find all the rational zeros of the polynomial. So this is just going to be another factoring one. Basically, we're thinking what two numbers multiply to give me 64, add to give me a negative 20. So this one's a little bit more difficult than the ones we've done in class as far as identifying the factors. However, I can kind of look at these, and I can kind of see, well, which one of these would kind of make sense, right? If these are my zeros, remember they're coming from factors. And immediately this kind of gives me an idea, like these are all going to be rational zeros. So that means it's going to be like coming from square numbers. They're all plus or minus. So immediately I think to myself, if I had x squared minus 20x plus 64, since that's positive, that means my factors both have to be negative since my middle term's negative. So if I'm thinking what two numbers multiply to give me that number, add to give me negative 20 that you could take the square root of, I automatically think here it's going to be negative 16, x minus 16, and then x minus 4. So therefore, if I need to get these same numbers to add here, I would get x squared minus 16 times x squared minus 4. And you can see that makes sense as well because, if you were to set these both to 0, the square root of 16 is plus or minus 4. The square root of 4 is going to be plus or minus 2. So obviously, we know that the two factors from like the previous problem we did is going to be squared and squared. Therefore, you're going to have a plus or minus, right? So it's either going to be, it can't be that one. It could have been that one. It can't be this one. So you're basically dealing with A, E, and C. And then understanding that this would have been x squared, minus 9, right? Which wouldn't have given you your answer. And this one would have been some really, really big number run there. So there we go from that. All right, last two. So the last one, or second to last one, says predict the end behavior of the graph. So one thing I like to do is just kind of rearrange this. The x cubed plus 4x, okay? Therefore, we see that the degree is odd and leading coefficient is negative. Okay, so if something is odd, if a polynomial is odd and it has a leading coefficient that's negative, we know that's going to fall to the left and rise to the right. So again, we got to understand, what this as x approaches infinity means. So as x, this arrow means approach. So as x approaches to infinity, that means going to the right, it's falling, right? F of x is approaching negative infinity, so that's not it. So as x goes to the right, that means falling. As x approaches right, it is falling again. So D is not the answer. Oh, wait, that's to the right. Oh, I'm sorry. I'm doing this end behavior wrong. Oops. As the graph falls, it's a negative, right? So it's actually rises to the left and falls to the right. So B actually could be your answer. And so as well as could D. So this one, as x goes to the right, it's rising, right? And that is not correct. As x goes to the right, that's rising. That's not correct. So now, as x goes to negative infinity, which means as the graph goes to the left, we need it to go up. Well, here it's falling. So here, that one works, and as it goes to negative infinity, it's rising, so you can see that one works. All right, last example on the quiz. We have the intermediate value theorem to determine whether a polynomial function has a real zero between the given integers. F of x equals 8x cubed plus 10x plus 2 between -1 and 0. So basically it's asking us, in between the interval -1 and 0, does the polynomial function have to cross the x-axis? And the way that we can show if it has to cross the x-axis is by determining if we have values of this polynomial that is one's positive and one is negative. And because we do have a polynomial function that we know is going to be continuous, right? And there's not going to be any breaks or holes or jumps here. So all we need to do is basically figure out what is f of -1 and f of 0. So it's kind of telling us what we need to do. We just need to see which work is going to make sense. So we take -1 cubed plus 10 times -1 plus 2. So any negative number raised to an odd power is negative, so that becomes a -8. Plus, I'm sorry, that's 10 times -1 is going to be a -10 plus 2. So -8 minus 10, you owe me $8, you borrow 10 more dollars, you owe me 18. That's going to be a -16. So therefore, I can say that one's not it, and that one's not it. Now let's figure out what f of 0 is. Because obviously if they have the same sign, then if they're both negative, then that doesn't prove the intermediate value theorem. If one is positive, one's negative, then you can say that it does, the intermediate value theorem does apply. So when I plug in f of 0, the nice thing about plugging in 0 is everything that has an x just goes to 0. I'll write it out just so you can see, but the answer is 2, right? Because all of that goes to 0, so you're left with 2. So since at a -1 it's negative, and at f of 0 it's positive, and since the graph is a continuous function, that means it has to go from a negative to positive, it has to cross the x-axis, so the answer is D. All right, and there you go, ladies and gentlemen. That is our quiz in our polynomials unit. Done.